Alright, so this is the notes for 8.7, which is about systems of inequalities. So in 8.1 and 8.2, we looked at how to solve systems of equations, but here we're going to have inequalities. We're going to have greater than or equal to, or less than or equal to. Now, a solution to a system of inequalities is any point x, y, that when you plug it into the inequality, it makes the inequality true. Now, one of the differences with systems of inequalities is sometimes there's not just one answer. Sometimes there's an infinite number of answers, that any number in this certain field will answer the question. Generally speaking, when we talk about inequalities, we graph them, because usually the graph allows us to see the solution set a little easier. When you draw the graph of these things, it breaks the coordinate plane into what are called two half planes, one on each side of the line. And generally, these inequalities are going to be satisfied by one of the half planes, but not the other half plane. Okay. So what we're going to do is we're going to start out with just graphing one inequality and seeing how that works. And then, after we've done that a little bit, we'll go into doing actual systems of inequalities. Okay. So how do we graph a linear inequality? These are the basic steps we follow. Step 1, we replace the inequality with an equal sign and draw the graph of the corresponding linear equation. We draw a solid line if the original inequality had an equal to in it, and we draw a dotted line if it was just a less than or just a greater than. Step 2, choose a test point in one of the half planes. The point needs to be not on the line, it needs to be somewhere else. And substitute that point into your inequality. If you get a true result, then shade that half plane that contains that test point. If you get a false result, then shade the other half plane. Okay? So let's look at how this works. So I'm going to first off come in here and draw my axis lines. Okay. So we are asked to graph 2x minus 3y greater than or equal to 6. So the first thing I'm going to do is I'm going to change that inequality to an equal sign. And I'm going to solve this for y so I can actually graph it. So I'll move the 2x over. Negative 3y equals negative 2x plus 6. And I'm going to divide everything by negative 3. So I get y equals 2/3 x minus 2. So this is a line that has a slope of 2/3 and a y-intercept of negative 2. So I'm going to go to where negative 2 is, I'm going to put a point, and I'm going to do a 2/3 slope, which means I'm going to go up 2 and to the right 3. 1, 2 over 1, 2, 3. Up 1, 2 over 1, 2, it'll be off here somewhere. Similarly, I could also go down 2 and to the left 3. 1, 2, 3. Down 1, 2, 1, 2, 3. It's going to be off here somewhere. So these are our points on this line. And we need to decide that when we connect these points, do we do it with a solid line or a dotted line? Because there is an equal to, we are going to do a solid line. So I'm going to go in here, and I'm going to draw a solid line connecting these points together. And I will put arrows on the ends to indicate that it does keep going. So that solid line divides the coordinate system into two planes, or rather two half planes. There's one up here above the line, and then there's another one down here below the line. So I need to pick a point that's in one of these planes to test with. I'm going to use the origin because it's a pretty easy number to deal with. So I'm going to test the point 0, 0. So I'm going to plug that into this original inequality. 2 times 0 minus 3 times 0 greater than or equal to 6. 2 times 0 is 0. 3 times 0 is 0. 0 minus 0 is 0. So I get 0 is greater than or equal to 6. Is that true? No, that's false. So since that's false, I don't want to include 0, 0. So I don't want to shade up here. Instead, I want to shade down here. So I'm going to shade in all of this space down here. and that's going to be how it works. Okay, so that's my solution set. Any point that's in this shaded area is going to be a solution to the inequality. Now, when you do these in my math lab, it works pretty much the same way. You're going to graph the line first, and then you'll use a little paint bucket tool to fill in which part of the plane you want to fill in. Okay. Let's look at another one. So, once again, we have an inequality. This inequality says y is greater than negative 2/3 x. So we're going to replace the inequality with an equal sign. Y equals negative 2/3 x. And then we'll graph it. This one's already solved for y, which is really nice. It has a slope of negative 2/3 and a y-intercept of 0. So it's going to go through the origin. The slope tells me I go down 2 and to the right 3. It's going to be off here somewhere. I could also go up 2 and to the left 3. Now when I connect these points, I need to decide if I connect them with a solid line or a dotted line. Because this is just a greater than, I am going to use a dotted line to connect them. Okay, so I have my little dotted line there. I am going to put arrows at the end to indicate that it does keep going. Then I need to pick a test point to figure out where I shade. I can't use 0, 0 this time because 0, 0 is on the line. So instead I'm just going to use this point up here at 1, 1. So let's test 1, 1. So if I plug it in, 1 is greater than negative 2/3 times 1. So 1 is greater than negative 2/3. Is that a true statement? Is 1 greater than negative 2/3? Yep, that is true. So since that's true, that means I want to include that point at 1, 1. So I want to include this point. So that means I'm going to shade this half plane up here. So I'm going to come in here and I'm going to shade all of this up here. So it's going to take me just a second to shade. That's going to be all in here. Everywhere in this little half plane up here is a solution. Okay. So that's kind of how that works. Now, if your equation is in the form y is greater than mx plus b or y is less than mx plus b, like this last one was, you don't even necessarily need a test point. Because they said y was greater than this, I already knew that it was going to be above the line. If it had said y was less than this, I would have already known it's below the line. Because anytime it's in this form where you have y inequality mx plus b, the greater than or less than basically just tells you which side of the thing to do it on. So if they're in that form, you can kind of do that. Although for most students, test points usually work better. Now, the same thing also works with horizontal and vertical lines. If you have a vertical line, x equals a, then x greater than a means shade to the right of that line, and x less than a means shade to the left of that line. If you have a horizontal line, y equals b, y greater than b means you shade above that line, and y less than b means you shade below that line. And just so you can kind of see it, we have some more inequalities here. I'm going to set up my grid first. Turn this back to solid. Okay, so here's my coordinate system on both of these. So this one we have y is less than or equal to negative 3. So I would go to negative 3 on the y, which is down here, and I would draw a horizontal line. Now, because this is an equal to, that's going to be a solid horizontal line. So it's going to be a solid line down here. And we'll put arrows on it to indicate that it keeps going. Now this says that y has to be less than that number, so that means we're going to shade below. So all of this area below here, all of that is our solution set. So vertical lines, horizontal lines, these are pretty easy to do. Same kind of thing over here. We have x is greater than 2, so we would go to where 2 is and we draw a vertical line. Because this is just a greater than, it's going to be a dotted vertical line. So I'm going to go here to where x is 2, I'm going to draw a dotted line. It's kind of hard to see it on top of the axis, but you know, it is what it is. So I have my dotted line here, I'm putting my arrows on the ends. Okay. But we want x to be greater than 2, so that means we want to shade to the right, so that we include numbers like 3 and 4. So all of this over here would be our answers. Okay, so not too bad. We can also do these inequalities with non-linear equations, equations that are not lines. Oops, I'm going to turn line into solid again. Solid. So we can do these things with parabolas or cubics or square roots or any other type of graph. Okay. So here in example 4, it asks us to graph this equation x squared plus y squared less than or equal to 9. As a reminder, this is the equation of a circle. Just in case you didn't know, x squared plus y squared equals r squared is the equation of a circle with radius equal to r. So in this particular case, 9 is our r squared, so r squared equals 9. So r equals 3. So this is a circle with a radius of 3. So from your center, you're going to go out to the right 3. You're going to go up 3. You're going to go to the left 3. And you're going to go down 3. Now, because this has an equal to, when we connect these points in a circle, we will connect them with a solid line. And just try your best to make it look circular. You don't want it to look like a diamond. You do want it to have a little bit of a curve to it so that it looks somewhat circular. It does not have to be perfect. It just needs to look somewhat circular. So there's our graph. Now we want to see where we shade, so we need a test point. I'm going to use the origin because it's not on the circle. So I'm going to test with 0, 0. So plug that in. 0 squared plus 0 squared less than or equal to 9. 0 squared is 0, 0 squared is 0, 0 plus 0 is 0. So I have 0 is less than or equal to 9. Is that true? Yep, it is true. 0 is less than 9. So we will include the point at 0, 0, which means we're going to shade here in the middle. So the middle of this circle will get shaded to answer our inequality. So any point that is here in the middle of this circle, inside of the circle, will be a solution to this system of equations. Okay. So any of these points is okay. Alright, so far everything we've done has been one equation in isolation. But now we're going to talk about solving inequalities that are systems. So you have multiple inequalities. With these, the way it works is you graph each inequality, figure out where each one would be shaded, and then look for the area of overlap. There will usually be some spot where the two shaded areas or three shaded areas all overlap, and that would be your solution for the system. Now, occasionally, you'll end up with equations where there is no overlap. And if there is no overlap, then that tells you that there is no solution to the system. Okay. So, let's look at some examples. Draw my axis lines in here real quick. Alright, so we have two different equations, or sorry, two different inequalities this time. Our first one, we have x minus y equal to 1. I'm going to move the y over and say x equals y plus 1. Move the 1 over, y equals x minus 1. So I'm going to graph that. That's a line that has a slope of 1 and a y-intercept of -1. So here's its y-intercept. Its slope of 1 means I go up 1 and to the right 1. So up 1 to the right 1, 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 up 1 to the right 1. I can also go down and to the left, down and to the left, down and to the left, down and to the left. So these are my points on this line. Now, because that inequality was a less than by itself, we are going to connect these with a dotted line. I'm just going to connect all of those together with a dotted line. And put arrows on the ends. And then I want to see which way we should shade it. So I'm going to use a test point. I'm going to use 0, 0 because it's not on the line. So I'm going to test 0, 0 for this original inequality. So 0 minus 0 is less than 1. 0 minus 0 is 0. So I have 0 less than 1. Is that true? Yep, that is true. Now, rather than actually shading this, I'm just going to put a little note to myself of which direction this should shade. So this thing should shade this way. It should shade up on this side to include 0, 0. So imagine that this part here is shaded in blue. Right, let's look at our other inequality. We have 2x plus 3y equals to 12. Move the 2x over, 3y equals negative 2x plus 12. Divide everything by 3. Y is equal to negative 2/3 x plus 4. So that's a line with a slope of negative 2/3 and a y-intercept of positive 4. So 1, 2, 3, 4. There's my y-intercept. My slope says I go down 2 and to the right 3. It's down 1, 2, to the right 1, 2, 3. Down 1, 2, 1, 2, 3. It's going to be off here somewhere. I could also go up 2 and to the left 3, which would be over here somewhere. When we connect these points together, because of the equal to, we will use a solid line. So I'm going to go from here and connect all of these points together. And I'll put some arrows at the ends there. And then I need to decide how this is shaded. So I need another test point. I'm going to test 0, 0 again, just to see if it's included. So if I plug that into this one, I get 2 times 0 plus 3 times 0 is greater than or equal to 12. 2 times 0 is 0. 3 times 0 is 0. 0 plus 0 is 0. So I have 0 greater than or equal to 12. Is 0 greater than or equal to 12? No, that is false. So for this one, I don't want to include 0, 0, so I would want to shade going this direction. Okay. So now I need to determine where is my area of overlap. Well, it's not going to be over here, because over here only the blue would be shaded, the green would not. It's not going to be down here because none of them would be shaded down here. It's not going to be right here because only the green would be shaded there, not the blue. It is going to be up here in this little corner. So I'm going to use red, just so it's a different color. So this would be my area of overlap. This would be the area where both of them would get shaded. So that's the little section that is the solution to this system of inequalities. Now, again, it's going to work the same way with my math lab. when you do the system, you're going to graph the two lines, and then you're going to pick which of the sections to fill in using the paint bucket. Okay, so just pick your area of overlap, and then click and fill it in. Here's another one. So here we have another system of inequalities. For our first one, we got y equals x squared minus 4. That is a parabola that's been shifted down 4. So remember with our basic parabola, we had these points, negative 2, 4, negative 1, 1, 0, 0, 1, 2, 4. This one, though, has been shifted down 4, so the x's are going to stay the same, but we're going to subtract 4 from the y's. So we'll have negative 2, 0, negative 1, negative 3, 0, negative 4, 1, negative 3, and 2, 0. I'm just going to be plotting these really quick. Oh, and I am connecting these with a solid line because of the equal to. Let's see, if I do one more point. I'd have another point up here and up here. If I take negative 3 and plug into this equation, I get 5. And if I plug positive 3 in, I also get 5. So this graph would also continue up to this point and then keep going. Same thing over here. It would continue up to this point and then keep going. So now we need to decide how we shade. We want to decide if it's inside the parabola or outside the parabola. So let's test 0, 0 real quick. So 0 is greater than or equal to 0 squared minus 4. So 0 is greater than or equal to 0 squared is 0, minus 4 is negative 4. Is 0 greater than or equal to negative 4? Yep, that is true. So for this parabola, we want to shade inside, so that way we include the origin. So we want to be inside of this parabola, in here somewhere. Look at the second inequality. We have x minus y is less or greater than or equal to 2. So it means we have x minus y equals 2. Add the y across, x equals y plus 2. Subtract the 2 across, we get y equals x minus 2. So that is a line that has a slope of 1 and a y-intercept of negative 2. So here's my y-intercept of negative 2. My slope of 1 means I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I can also go from this point and go down 1 to the left 1, down 1 to the left 1, down 1 to the left 1. Now when I connect those points together, it will be with a straight line that is shaded, not dotted, because it is solid because of the inequality there. So I connect all those points together, put my arrows on the ends, and then I need to decide how to shade this line. So again, I'll do a test point of 0, 0 because it's not on the line. So 0 minus 0 is greater than or equal to 2. 0 minus 0 is 0. So if 0 is greater than or equal to 2, is 0 greater than or equal to 2? No, that one is false. So with this line, we want to shade so that we don't include 0, 0. So I want to be shading away from 0, 0. So we need to find the area of overlap. It's not going to be up here because that would not be shaded by either of them. It's not going to be over here because it would only be shaded by the blue there. It's not going to be here because it's not going to be shaded by any of them. It's also not going to be down here because it would only be shaded by the green down here. Instead, it's going to be this little section right here that's inside the parabola but below the line. So it's this little bit in here is the area of overlap between these two. So any points that are in that little shaded region will be solutions to the system of inequalities. Alright, let's look at example 7. So this one we actually have 3 inequalities. Our first one we have x minus y is less than 2. So that's x minus y is equal to 2. Add the y over, x equals y plus 2. Subtract the 2 over, y equals x minus 2. So with a line with a slope of 1, a y-intercept of negative 2. So there's my y-intercept at negative 2. We go up 1 to the right 1, up to the right, up to the right. We can also go down and to the left. So these are all points on that line. When we connect the points, because this is just a less than, we will use a dotted line to connect. And then we will put arrows here at the ends. And then we want to decide how does this get shaded. So we will test a point 0, 0. So 0 minus 0 is less than 2. 0 minus 0 is 0. So we have 0 is less than 2. That is true. 0 is less than 2. So on this one we want to shade up above this line. So that way we include the point at 0, 0. Our second one is a compound inequality. Okay, this says that negative 2 is less than or equal to x is less than 4. This is actually 2 different statements. It's saying that the x has to be greater than negative 2 and the x has to be less than 4. So any number between negative 2 and 4. Now this one, because it has an equal to, it's going to be a solid line. This one, because it's just a less than, is going to be a dotted line. So at 4, 1, 2, 3, 4, we're going to have a dotted line going up and down. And then at negative 2, we'll have a solid line. And so what this compound inequality is saying is that x has to be between these two numbers. So for this equation, it's got to be between these two lines. Anywhere in between the two of them is okay. So right now our area of overlap is this kind of trapezoid shape right here that is above this dotted line going diagonal in between these two vertical lines. So it's this little shape right here. But then we have one more equation. We have y is less than 3. Well, that's going to be a horizontal line at y equals 3. And it's going to be dotted because it's just a less than. So we're going to do a dotted line there. And for this one, because we want the y to be less than this number, we would shade below, so it would shade down here. And so our final answer ends up being this kind of trapezoid shape in here that's in between the two vertical lines, below the horizontal line, but above the diagonal line. So anything in this kind of trapezoid shape is okay, as long as it's in between the two horizontal, below, or in between the two vertical, sorry, below the horizontal and above the diagonal line. Okay. So that is my solution to this system of equations. This is our last example. get my axis lines down real quick. There we go. Oops. Let me fix that one. Alright, so here we have two more equations. Our first one is y is greater than or equal to x squared minus 4. So that means I have y equals x squared minus 4. We actually just graphed that parabola a second ago. It had a point at -2, 0, -1, -3, 0, -4, 1, -3, and 2, 0. And we also found that at -3 it was up at 5, and at +3 it was up at 5. And so this was what that parabola looked like. And it would be solid lines. Oops. It would be a solid line because of the equal to on the inequality. So it looks something like that. We do need to test, though, to see where we shade. So let's test the origin, 0, 0. We have 0 greater than or equal to 0 squared minus 4. So 0 is greater than or equal to 0 squared is 0. 0 minus 4 is -4. Is 0 greater than or equal to -4? Yeah, it is. So that's true. So on the parabola, we do want to shade inside the parabola, so that way we include the point at 0, 0. Point right there. Let's look at our other equation, x plus y less than or equal to 2. So we're going to be looking at x plus y is equal to 2. Just subtract the x over, you get y equals -x plus 2. This is a line with a slope of -1 and a y-intercept of +2. So I'm going to go up to +2 and put a point. My slope is -1, which means I go down 1 and to the right 1, down 1 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 to the right 1. I can also go up 1 and to the left 1. So up and left, up and left, up and left. And when we connect these, it will be with a solid line because of the equal to there. So I'm going to connect them all together. And then I will put arrows on the ends to show that it keeps going. And then I need to test. I'm going to test 0, 0 because it's not on the line. So 0 plus 0 is less than or equal to 2. 0 plus 0 is 0, so I have 0 less than or equal to 2. That is true, 0 is less than 2. So with this line, we would want to shade below it, so that way we include that point at 0, 0. And so then our area of overlap, where both of them would be shaded, is this area here, which is inside of the parabola, but below that line. So that would be my area of overlap between these two things. Okay. So that's my solution to this system of inequalities. And that wraps up 8.7. As always, if you have any questions, please feel free to send me an email.